Welcome to Daily Papers, the podcast where we break down the latest academic research and make it accessible for everyone.
Today, we're looking at a paper that maps out the family tree of some of the most famous AI models in the world. It's called From GPT-3 to GPT-5, mapping their capabilities, scope, limitations, and consequences.
Right, and if those letters GPT sound familiar, it's because they're the engine behind ChatGPT, the AI that took the world by storm. This paper helps us understand how we got from a niche tech tool to something your grandma might use to find a recipe.
Exactly. The authors aren't just giving us a history lesson. They're comparing how each generation of GPT got smarter, how we interact with them changed, and what problems have stubbornly stuck around.
So let's rewind a little bit to the ancestor of the family, GPT-3. Before ChatGPT, this was the model that made everyone in the tech world sit up and pay attention.
But it was very different from what we use now. The paper describes it as a scaled few-shot text predictor. In simple terms, it was incredibly good at completing text. You'd give it a sentence, and it would finish it for you.
And what does few-shot mean?
Think of it like this. If you wanted it to write in a certain style, you had to give it a few examples first. You'd show it 2 poems and then ask it to write a third one. You had to be a bit of a wizard, a prompt engineer, to get the best results. It wasn't really a conversational assistant.
So it was a powerful engine, but you needed to know how to drive it. Then came GPT 3.5. This, the paper argues, was the real game changer for the public.
This was the revolution. This is the model that powered the first version of ChatGPT that everyone started using. The big shift was from being a completion engine to a chat assistant.
The interaction completely changed. Instead of carefully crafting examples, you could just talk to it. You could say, "Tell me a joke," or "Explain black holes like I'm 5."
And that's because of something called instruction following. The researchers trained the AI specifically to understand and follow human commands. This made it safer, more helpful, and 1,000,000 times more user-friendly. It opened the door for everyone, not just the experts.
After that, the pace really picked up with GPT-4. This was a massive leap in raw intelligence. The paper notes that GPT-4 smashed all sorts of benchmarks, even passing difficult professional exams like the bar exam for lawyers.
And it learned a new trick. It could see. This is what the paper calls multimodality. That just means it can handle multiple types of data or modalities. So with GPT-4, you could give it an image, not just text, and ask questions about it.
Then came GPT-4o, with the O standing for Omni. This took that multimodal idea and put it into overdrive. Suddenly, the AI could see, hear, and speak in near real time.
Right. The goal was to make interacting with it feel more natural, more human. You could have a spoken conversation, interrupt it, show it things with your phone's camera. It was less like typing a query into a search box and more like having a real assistant.
But the family has different branches. The paper also talks about versions like GPT 4.1, which was less about flashy demos and more for serious developers. It was designed to handle huge amounts of information at once.
They call this long context. Imagine trying to discuss a book with someone who can only remember the last sentence you said. That's what early models were like. A long context model is like someone who has read the entire book and can remember every detail from every chapter.
This brings us to the latest generation discussed in the paper, the GPT-5 family. And family is the key word here. It's not just one single massive model.
The paper describes it as a routed system. It's a clever idea. Instead of using one giant, energy-hungry brain for every single question, the system has a manager or a router. When a request comes in, the router sends it to the best model for the job.
So if you ask a simple question, it goes to a fast, efficient model. But if you ask a really complex, creative question, it gets routed to the big, powerful, deep thinker model.
Exactly. But this makes things more complicated. When you're using it, you don't really know which model you're talking to. The system is making those choices for you behind the scenes. It's evolving from a tool that answers questions into an agent that can complete complex multi-step tasks.
But for all these incredible advances, the paper is very clear that some problems have been really hard to shake off. They're like persistent family quirks that get passed down through the generations.
The most famous one is hallucination. It's a great term. It basically means the AI will confidently just make things up. It can invent facts, cite books that don't exist, and sound completely convincing while doing it.
And that hasn't gone away even in the newer models. The paper also points to other recurring issues like bias creeping in from the training data and a growing lack of transparency. With early models, we knew a lot more about how they were built. Now, it's more of a trade secret.
So, what's the big takeaway here? The paper's main point is that this evolution isn't just about the models getting bigger or scoring higher on tests. It's a fundamental change in what an AI system is.
We've gone from a pure text predictor that you had to handle with care to a conversational partner, and now to a complex, multimodal, tool-using system that's deeply woven into our apps and workflows.
The relationship has changed. We've moved from giving the AI a task to integrating it into our society. And the paper concludes that this means we have to think differently about how we govern this technology to make sure it's safe, fair, and beneficial for everyone.